Bismillahirrahmanirrahim. Uh, this is lecture number 1 on the request of the other section. I am making this video for the section 1 because they are not familiar with the basics which I have taught in the first 3 lectures in the university. So these 3 lectures will cover the basics of this, what is science, what is the dynamics, what is scalar quantities, vector quantities, dot product, cross product, and we talk of the kinematics and kinetics, the velocities, the accelerations, the relationships, and the distance time graph, velocity time graph, and the acceleration time graph, what they represent. So I hope this will help the students which have not being attended the initial lectures. So let's start. Basically, the book which I have already told you, the recommended book which I am using is Engineering Mechanics Dynamics by J.L. Mariam and L.G. Gregg. It's the 7th edition. Now, students, I quote, you are the students of science for the last, I think so, 4 years. What is science? Science is defined as the growth of ideas through observation and experimentation. Or some people say it is the knowledge gained by man, of course, through keen observation and experimentation. There's some knowledge which we gather by the observation. We know the sun rises in the east, it sets in the west. The seasons are changing day and night. These are the knowledge we obtain. Of course, this is also a science, and that is the observation. And then the experimentation. When you do the experiment, you also get some observations, record the readings, and of course, to conclude some results. So science is the knowledge which basically deals with 2 things. One is the observation, another one is the experimentation. Now, what is applied science? The branch of science which coordinates the research work. Of course, the scientists are doing the research work for practical, but the applied science basically coordinate with the research work for practical utility and service of the mankind. That is known as applied science. How the basic idea of the science can be used for the betterment and for the practical utility of the human being. For example, scientists invent that when light falls on certain materials, electrons are emitting. It's a photoelectric effect. But the technology basically tried to make the solar cells and then solar panels for practical use of the mankind. Engineering, that because you are the students of engineering. So what is engineering? Engineering is the application of mathematics, of course. We use the mathematical relationships. Some relationship we get empirical evidence, that is experiment, and scientific. And we also see what is the economic, social impact, and the practical knowledge in order to invent, innovate, design, build, maintain, research, and improve structures, machines, tools, systems, components, materials, processes, and organization. So basically, engineering is the idea or the basic concept of a science to bring into reality, right, in a better way, which is economically viable, socially acceptable, and for the betterment of the human being. So we are the people which are not having new scientific ideas, where we're using the same basic ideas, but we bring that particular knowledge into reality for the practical use of that knowledge. So I'm moving towards the actual course, that is mechanics, engineering and mechanics. Mechanics is the branch of applied physics dealing with motion and forces producing motion. It deals with the motion, velocity, displacement, acceleration, and of course what produced this, which is basically the motion, or Mechanics is the science we describe and predict the condition of rest or motion of a body under the action of force. It can predict whether the body is at rest, whether the body will in motion, and what is its position after some time, and of what is its velocity and acceleration. So mechanics is basically dealing with the motion of a body due to the forces which produce it. Mechanics is an area of science concerned with the behavior of physical bodies when subjected to forces or displacement and the subsequent effects on the bodies on their environment. So mechanics basically deals with the physical bodies. What will happen to physical bodies when the forces are applied? Whether they are stationary like structures, like houses, like bridges, whether they move like cars, aeroplanes, ships, right? So what will be the effect on the physical bodies when certain forces are being applied? We are dealing with the applied mechanics. Applied mechanics is a branch of physical science and the practical application of mechanics. Right? It's a branch of science, physical science, of course, but it is the practical application of mechanics. Applied mechanics describe the response of the body, solids and fluids, or system of body to external forces. Okay, for example, if force is applied on a certain body, does not move, of course, it is stationary, it is at rest, like your buildings, like the bridges, right? These are the basically in statics. But the body is moving, for example, if it is moving with uniform velocity, or it is moving with acceleration, moving with uniform acceleration or variable acceleration. What is the status of this? That is basically discussed in applied mechanics. So, students, of course, the mother of all is physics. And out of physics, we get mechanics, thermodynamics, and electricity. I'm talking of in terms of my engineering applications. Then from mechanics, we have statics and dynamics. That we have statics we have studied in your previous semester. So that is we are talking of today is dynamics. And dynamics, we have again two branches or two different fields in which we will study. That is kinematics and kinetics. Statics, of course, statics is the branch of engineering mechanics which deal with the forces and their effects while acting upon a body at rest. The degree of freedom is zero. The sum of all the forces is zero. The moment is zero. The equilibrium condition is being applied that we have solved, like the houses, buildings, bridges, trusses. Here, the effect of all the forces acting on a body is zero, right? And of course, its moment is also zero. Those statics mean structures. When we talk of structure have a degree of freedom is zero. Now, let's move to our course, that is dynamics. It is that branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies in motion. Right? What is the effect of the forces on the body when it is in motion? This further dynamics is being divided into two main branches. I have already told you that are kinematics and kinetics. Kinematics is a direct branch of dynamics which deals with the bodies in motion without any reference of the forces which are responsible for the motion. We do not discuss the cause which produced that particular motion. We only discussed the effect of the forces, that is, we find position, velocity and acceleration of a body, that we are doing in chapter number 2. Kinetics. Kinetics is the branch of dynamics which deals with the bodies in motion due to the application of forces. Now, we also deal with the motion and the cause which produce it. And the cause which is produced, which is basically the forces. So F is equal to ma. We are talking of the forces and their effect, that is position, velocity and acceleration. Sorry. Dear students, there are certain terms which is used in mechanics. So I think I have to clarify all these things. So rigid body, the relative movement between its parts are negligible. A body is rigid, a limb is rigid, a part is rigid if there is no relative motion between 2 points on that particular part. That is called rigid body, right? Like a tire, like a arm of a robotic arm, right? These all of them are rigid body. Like a plane, it's a rigid body. Its shapes is not to be changed in normal circumstances. Dynamics dealing with the rigid body in motion. Dynamics deal with the rigid body in motion. I'm talking of the dynamics. So length applied to the linear dimension of a straight line or curved line. Straight line or a curved line, length is basically the length. Whether if I say it's a curved length, if it's a circle, it is 2 pi r or pi d. If it's a straight line, it's 0.1 to 0.2. Area, it's a two-dimensional thing, of course. It is the surface occupied by any body. Volume is a space occupied by any body. There's a length, width and height. Forces, the action of a body on another, whether it's push or pull the force. Force is an agent also which produce or tends to produce, which stop or tends to stop the motion of a body, either of pushing or pulling. Mass is the amount of matter in a body and is a measure of inertia. Larger mass, heavier body, of course, have a heavier inertia, and smaller body will have a smaller inertia. Weight is the force basically with which Earth attracts any body towards its center of gravity. Particle, I have also given the introduction in my lecture 3. A body of negligible dimension, we say, but in our case, we take a complete body like a ship or like a car, like a ball, to small particle, from small body to a larger body as a whole. That is called particle. Very quickly, I go through the first Newton's laws of motion. Newton's first law of motion: every object persists in a state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. I think you have studied like this in your classes, the same thing. A body at rest remains at rest. A body in motion continues motion unless some unbalanced force acts upon it. I have given you the example of this. For example, this is the rocket. You see object state rest, airspeed is initially 0. Now we fire, the thrust weight is downward and thrust in the upward direction. And of course, there is some resistive force from the air. The net force is thrust minus weight. If it is positive, the rocket will move in the upward direction. And if it is negative, of course, rocket is not to be accelerated or stationary. But if it's positive, the body, it will accelerate and the velocity will increase. The net. So it will be a state of rest when the upward thrust is less than or equal to the weight. When it is slightly larger than this, then the net force the body will move. That is the main principle of the or law of the Newton's first law of motion. Newton's second law of motion says if a force is applied on a body, it will produce acceleration in a body. That acceleration is directly proportional to, of course, the applied force and inversely proportional to the mass. In simple differential form, it's a change of momentum, dmv by dt. The rate of change of momentum is also called force, or F is equal to ma, or I can also write F is equal to m1 v1 minus m0 v0 t1 minus t2. Mostly the mass is constant. We can also take m v1 minus v0 over t1 minus t0, or F is equal to ma, that you have already studied. So force, acceleration, momentum and velocity are all vector quantities. So force is also a vector quantity. So in both ways we can describe for F is equal to ma, force is directly proportional to, so acceleration is directly proportional to force, and acceleration is inversely proportional to mass, or the rate of change of momentum is called force. Newton's third law of motion: every action has an equal and opposite reaction. Let's see if I'm pressing the wall with my finger, then of course I'm applying the force with the blue line, and then the reaction is in the opposite direction. These both are equal, therefore the wall is stationary or my hand is stationary. If anyone increases, a lot of example, when you are walking, you are basically pushing the ground in the backward direction, you are moving in the upward direction. When the bird is flying, they are pushing the air in the downward direction. As a result, they are moving in upward direction. And just in the previous slide, I've given you the example of the rocket. Rocket pushes the gases are pushing the ground in the downward direction, and as the result, it's moving in the upward direction. So you are sitting on the chair. Of course, your weight is in downward direction, and the reaction of the chair in the upward direction. Both are equal. Therefore, it is stationary. Newton's third law of gravitation. Newton says that any two material body will have a force of attraction. This force of attraction is directly proportional to the product of masses and inversely proportional to the square of distance between their centers. Right? If this is a square centers, so F is equal to G m1 m2 upon r square. G is called gravitational constant. M1 and m2 are the masses. R is the distance between their centers, and the value of G in SI system is 6.67 into 10 raised to the minus 11 Newton meter square per kilogram square. One question you must ask, that why we do not feel a force of attraction between me and the wall or between two persons? Because your masses are small and the value of G is very small. It's 6.67 10 raised to the minus 11. Therefore, you will not feel a significant force of attraction. But in case of you and the Earth have a large mass, which is 6 exponent 24 kilogram, right? In this case, you feel the force, which is the weight. Of course, in science, everything is measurable, and there must be a standards through which we can measure. So units are things in which we measure different quantities. So how these things are being made, or units are being described, these are some fundamental units, derived units, and supplementary units. Fundamental and supplementary units, of course, you know that there are 7 fundamental units which is described by International Union of Weights and Measures, which is length, mass, time, temperature, amount of substance, light intensity, and current. And there are 2 supplementary units which is not to be put yet, neither in fundamental quantities and neither in the derived quantities, which is a plane angle, which is radian, and the solid angle, which is a steradian. Derived units, all other units basically, except these 7 supplementary units, they are basically represented in terms of these fundamental units, like velocity, acceleration, force, momentum, torque, energy, work, volt, etc. A lot of units. System of units which we come across is the CGS system. Centimeter is a unit of length, gram is a unit of mass, second is a unit of time. FPS system, it's a foot, pound, second. F is which is foot, is a unit of length, pound is unit of force, and second is the unit of time. MKS system is a meter for unit of length, kilogram unit of mass, and S is unit of second. SI unit is international system of unit. It is somewhat modified system of MKS system. International system of unit, a system of physical units which are already based on the meter, kilogram, and second, and these 7 other these 7 fundamental units: ampere, Kelvin, candela, and mole. Meter is a unit of length, kilogram is a unit of mass, second unit of time, ampere is a unit of current, Kelvin is a unit of temperature, candela is a unit of light intensity, and a mole is the amount of substance. And together we use the set of prefixes to indicate multiplication and division by a power of 10. Prefixes, I think you come across this: kilogram, mega, giga. These are the basically prefixes. Please see, is a deca is a 10 is for 1 is 10, hecto 100, kilo 10 is for 3, mega 10 is for 6, giga 10 is for 9, tera 10 is for 12, peta 10 is for 15, exa 10 is for 18, zeta is 10 raised to power 21, and iota is 10 raised to power 24. And the fractions are, which is deca is 1 by 10 10 to the minus 1, deci 10 10 to the minus 2, milli 10 to the minus 3, micro 10 to the minus 6, nano 10 to the minus 9, pico 10 to the power minus 12, femto 10 to the power minus 15, atto 10 to the power minus 18, zepto 10 to the minus 21, and yocta is 10 to the power minus 24. These are the prefixes we use as a kilogram, some megagram, kilometers, picofarad. So we use prefixes before this two prefixes cannot be used together. Micro, macro, no, it's pico. It will not be milli micro, it should be nano. So we cannot write two prefixes together. This is also one of the table which I've shown you. Of course, this is tera, T, G, M, K, tera for T, capital G for giga. This is for, of course, mega or million. Kilo small k, hecto small h, deca da, deci small d, centi small c, meter m, micros mu, and nanos and pico is p. So this complete my lecture number 2.